In this section, we'll be learning about the concepts of object-oriented programming in Java. So in this video, I'll be covering few important topics, and this is the introduction, and we will learn very basic things here. So I'll be talking about principles of object-oriented programming, and these principles are actually related to real world. So I will show you through examples how they are related to real world. Then we will learn about class versus object. What is the mean by class and what does it mean by object? Then we will take an example of a class and an object in Java, and we will see how a class is written and how an object is created in Java. So let us start with principles of object-oriented programming, that is concepts of object orientation. Let us look at the principles of object-oriented programming. The principles are abstraction, encapsulation, inheritance, and polymorphism. So these are the principles of object-oriented programming. Now, one important thing, learning object-oriented programming is different and learning Java is different. So I say separate them, right? So learning object-oriented programming concepts, if you have a grip on these concepts, then you can learn any programming language which is object-oriented. It looks very easy. So you know the principles, just you have to learn how to write that in that particular language. So like C++, Java, C#, Python, all these are object-oriented programming languages. So if you are good in concepts of object orientation, that is sufficient. So for Java, it is must for you to understand these concepts. Without that, you cannot learn anything in Java further. Just we have finished basics like operators and conditional statement loops. Those are simple things, very simple things. That is nothing compared to the concepts that are available in Java. So from here, the actual Java part starts. So focus on these videos and don't skip anything, watch everything. And if you are missing anything, then you rewatch the video and make sure you are much comfortable with these concepts. So let us learn these concepts independent of Java programming first. Then we will relate it with Java. So to explain these concepts, I have taken the example. So as I said that these concepts are more related to real life things. So actually real life engineered things, right? What all man-made things are there, it's related to that. Let us see. Here, I have taken an example of a television. This is an old TV box, idiot box, people used to call it as. This is an old television, and this is a new latest television, maybe LED, LCD, whatever it is, or plasma. Then, here I have a car, that is hatchback car, and I am showing the internal details here, a seat and a steering and all these pedals for brake and clutch and accelerator, and this is that is gear shaft. Now this is an engine inside. Now this is another car, that is a sedan car. This is hatchback. It's an extension of the same thing. This is a sedan having some extra feature compared to that. Now I have few more diagrams here. So using this, I'll explain. Let us observe. Abstraction. What is the meaning of abstraction? Abstraction means hiding internal details and showing only required features. This is what we find in other engineering also. Let us see what does it mean. See, this is a television. How it works? There is some electronic circuitry inside. All the functionalities are done by electronic circuitry. You want the television to work according to you. So you don't have to open the box and play with the wires or the circuitry inside, but you use only these buttons. You press this button, it will switch on. Again press it, it will switch off. How it is happening? You don't worry about that. What you want, you do it. I want to change the channel. Press the button, channel will change. How it is changing? You don't worry about it. Those are the internal details. You don't have to know how it is working, right? So just focus on what you want. So for making a user to use the object very easily or things easily, we follow this principle in all other engineering. Now, same abstraction I'll explain here. Again, I repeat, abstraction means hiding internal details and showing only required features. Let us take a car. If a driver is sitting here and he wants to use the car, just he should bother about what he wants. If you want to turn the car, use the steering. If you want to speed up, use the accelerator or change the gears. Just focus on this one. How it is happening internally inside engine, you don't worry about it. So it is there in the car. Yes, it's there. It is there with me. It is running with me in the car. But you don't have to know internal details. So we avoid showing internal details and show only required feature. This is called as abstraction. Abstract means we don't know what is there inside. So we see only the things that we require. So the same thing we want to follow in software or in programming also. How? We will see that later on. Just I give you the idea, clear-cut idea about the concept of abstraction. Now you stick to this one. Whenever I'll be discussing about anything related to abstraction, you have to think of these examples. Now next one, encapsulation. So in the real world, the other engineering streams, there we find encapsulation is done. What does it mean? See, these buttons are visible outside, no doubt, in a television. But where the circuitry is, can you see those wires and all that board or ICs? Can you see them? No, they are hidden inside a complete body. You cannot see them. So they are capsuled. It's capsuled, encapsulation. So everything is in a single capsule, in a single box. That's what. So a complete television means a single box. It's not that a screen is here and buttons are in that corner, right? Corner of a room, and the circuitry is another corner of a room. It's not open in pieces. It's like a single box. If you take the example of mobile phone, it's a single box. Encapsulation. If you take a car, just doors are there to get inside the car, and also at the back you can store something. But if you see the complete car, it's a single body. It's look like a single piece, and it's like a capsule, means everything inside. It's not that the engine is hanging outside or something is just dragged by the car that is connected to the car and is dragging. The pieces are not there. It's not separate pieces. It's completely a single body. So whenever we engineer anything, we try to make it as a single body, encapsulate everything, put everything inside the box. So that's it. Unboxing or encapsulation. This is boxing up or encapsulation. So we want to achieve the same thing in software also. Alright. In other engineering, what all we are doing, we want to do the same thing in programming also. So first understand how it happens in other engineering. So that is the reason I have taken the examples and explaining you. So these are the two important things. Now next thing is inheritance. What is this inheritance? See, in other engineering, we find that a television making company is making some television, and in that same television they will add a few more features and introduce it as a new model. New model of television is not a completely a different thing, but it's the same old television with some extra features. Same old television with extra features. Now if you see historically, decades back, this type of televisions were there. Now these type of televisions are there. There are a lot of televisions in between them. So it has been transforming and become more and more slim. But the idea of inheritance is already you have some engineered product and you are making a similar one and you want some extra features. So if whatever the work you have done, you don't have to do it again here. Just take it as it is, add a few extra things. That's all. A new model or a new product is ready. So this we do commonly. Like if you take the mobile phones now, if you take the example of iPhone 6, it is have what all the features it's having. Then if you take iPhone 7, same features are there, plus some extra features are there. Extra features, some extra features. Like one to mention that home button is not a physical button in iPhone 7. Now from 7 to 8, if you come, augmented reality AR is there. So like that, extra feature is added, and the same mobile phone, almost everything is same with some extra feature. This is nothing but inheritance in engineering. So inheritance in electronic engineering, and if you take the automobile, a car is there and the same car, but it is sedan car with extra space or maybe some extra features. This is inheriting from this one, borrowing all the features. So this is common in other engineering. So same thing we want to do it in programming also. If we have written some piece of code, we want to reuse that code again so that we don't have to write on the same thing once again. This is the idea we want to reuse. So here also reusing is there, right? Whatever the design of the car is, it is reused here. So we want to reuse the code. So that is the meaning of inheritance. Now coming to the last feature, that is polymorphism. Now before explaining about polymorphism, I'll show you the difference between inheritance and polymorphism. See, there is something called specialization and generalization. So I will write down here. Specialization and generalization. Specialization means if you already have something and if you are making some changes in that and adding more features and coming up with some new thing. So there's a specialized one of this type. There's a specialized one of this type. So already something is there and you are adding more few features and introducing something new. So you are specializing it. So specialization means inheritance. Specialization means inheritance. Like this is inheriting from this television and this is inheriting from this car. So that is inheritance. Now next thing, generalization. Generalization means if you have few things that are similar properties and all, you can make them under one group. You can group them. And always when you are referring, you can refer with a group name. That is easy for reference. Like all the students who are studying Java, Java students. So Java students or Java class students. So that single word will refer to all the students. Now same way, if you have LG, Samsung and Sony televisions are there, so you can say television. So LG television is also television, Samsung television is also television. So just you can use the word television to refer any television from any brand of any type, right? Whether it is a CRT television or plasma or LCD. Any type of television, you can say TV, television, just television, right? Or I just wrote a TV there. So this is a general term. Now, same way, if you take the cars from Toyota company or Suzuki or Hyundai, and we call all of them as cars. So we use a general term. This is a generalization. So what is the benefit of specialization? What is the benefit? So what all is there, we borrow everything and add more feature, put little more efforts to achieve this one, right? Little more effort to make this one. Then what is the purpose of generalization? You can refer a set of things together under one name. So it's easy for handling many things by just one single reference. Just to give you one example, once again, if I say students, so all will turn back to me. So just one word is turning the heads of lots of people. And one more example, a traffic signal, a red light will stop all the vehicles. That is for vehicles. All vehicles will stop. So one light is enough for referring to all the vehicles to stop. So it's giving a signal, it's giving a message to so many things together. Otherwise, a red light for cars, green light for sedan car, and yellow light for trucks, and orange light for, you should have many lights like that. But one red light refers to all vehicles. So one message is enough for communicating with so many people. So that's the benefit of generalization. Now one more thing, I'll throw an example, I'll show you what is the benefit of this one. See, when you learn how to use a television, you will not learn how to use LG, how to use Samsung, every television you will learn. No, you will learn how to use television. Whichever the type of television is, you can easily use it. Now same way, you don't learn Toyota car driving or Suzuki's driving or this driving, you learn car driving. So if you learn car driving, you can drive any car. They are all generalized. That's what the benefit in other engineerings we find. So the same thing we want to achieve in programming also, that we will do it in the form of polymorphism. This is polymorphism. Alright, so polymorphism is same as generalization and inheritance is same as specialization. So inheritance means specialization and polymorphism means generalization. These are the type of things we find in other engineering streams, and we want the same thing to be achieved in Java programming or object-oriented programming also. So now the ideas what I have gave you, that is the ideas how you should think, right? So that is thinking in Java. I have just started. There are lots of things to cover in Java and you will be getting practice of thinking in this fashion. So think in terms of real life world things, then you can apply them in concepts in programming. Next we will see what does it mean by class and what does it mean by object.